Okay, so now we're going to solve these polynomials that are not factorable by using uh, synthetic division. But before we do that, we'll have to list our possible rational zeros. So that's our first step, step A. So what we'll do here is you want to list all the factors of 12. And so let's see, that's going to be positive and negative 1, 2, 3, 4, 6, and 12. So those are all the factors of 12, values that divide evenly into 12. And then the leading coefficient in this case is 1, so you'll just divide all those by positive and negative 1. So basically you get a repeat of the numerator values here. So those are our possible rational zeros, okay? And so I just start in order. I'll start with 1 and then negative 1, 2, negative 2. And once I get 1, then the others should come fairly easily. So let's see. So I'll set up my synthetic division. So let's see, 1, negative 2, negative 11, 12. And so like I said, I'll just start with 1, see if that works. So let's see, drop down the 1. 1 times 1 is 1, adds to negative 1, negative 1. See, this adds to negative 12. Negative 12 times 1 is negative 12. And I got lucky. The first one does give me a remainder of 0. That won't always be the case, but this one worked out pretty nicely for me. So that means that I know that 1 is one of my solutions. Um, so looking back at my steps, so use synthetic division. Oops. Use synthetic division to test possible rational zeros to find an actual one. So these are possible ones. I found an actual answer. So I know one of my answers is 1. Now what I'm going to do is use the remaining part to find my other zeros. So what I can do is I can go ahead and write this as x squared minus 1x minus 12 from my synthetic division, right? So basically what I did was um, I factored this original one up here just to make sure we're understanding the whole picture here. Basically, what happened was I was able to factor this using synthetic division, and I guessed that 1 would work, and it did work, which is nice. So now I'm down to this as my polynomial, and this right here can just be factored by using simple methods. So we'll go ahead and factor this. So I have to figure out what multiplies to give me negative 12, but add up to that negative 1 in the middle. So that should be a minus 4 and a plus 3. So that's what this trinomial factored into. So then part C, I'm going to go ahead and so I used the quotient from part B to find the remaining zeros. So now I know all my solutions. So my solutions are 4, negative 3, and positive 1. And it doesn't really matter what order you put them in, just as long as you have all three of them. So all three of those are basically x-intercepts to this polynomial right here. They're the zeros. Okay, let's try another one. Okay, so once again, the first step is listing all my possible rational solutions. So I got to do all the factors of 6. So positive, negative 1, 2, 3, and 6. And on the front end this time I have positive, negative 1 and positive, negative 2. Okay, so you have to list all the combinations of the ratios that occur here from this set. So when you divide by positive and negative 1, that's just going to give you a repeat of the top. So positive, negative 1, 2, 3, 6. Now what we'll do is we're going to divide all these, come up with all the ratios dividing by 2. So let's see, that will give us positive and negative 1/2. Then 2 divided by 2 is 1. That one's actually already here, so don't need to repeat it. And then 3 divided by 2, we'll go ahead and include that one. So 3 over 2. And then 6 over 2 and negative 6 over 2, that's going to give us positive and negative 3. It's already listed, so I don't need to list it a second time. So those are all my possible rational solutions. And so once again, you can just start at 1 and kind of go down the list. If you really want to, you can start at 1/2 or, you know, -3/2 or whatever you want. But I like to go in order because if not, I might do the same one twice. So, okay. So we'll set this up. So let's see, 2, -3, -11, 6. So I'll start with a 1. So we'll drop the 2. 2 times 1 is 2. That adds to -1. -1 is -12. That gives us -12. That adds to -6. So my remainder was not 0. So that means, all that means is 1's not a solution. That's all it means. Just means I got to try something else. So I'll try -1. Okay. So we'll drop the 2. Let's see, 2 times -1 is -2. Let's see, that gives us -5. That gives us +5. That will give me, what is that, -6. That will give me +6. And, uh-oh, 12. Okay, that one doesn't work. Okay, so next I would try 2. I'm actually going to do -2 just because I know that one works, just so that this video isn't forever. All right, so let's see. 2, -3, -11, and 6. Okay, so we'll drop the 2 down. 2 times -2 is -4. That adds to -7. That multiplies to give me +14. That adds to 3. 3 times -2 is -6. And there we go, remainder of 0. Okay, so what we basically did, just to kind of review, we basically factored the problem. We basically factored the polynomial into 2x squared minus 7x plus 3. And then since that gave me a remainder of 0, that means that the factor is x plus 2. Because see, if I plug in -2, it would cause this to equal 0. It would cause the whole function to equal 0. And so that's what we're trying to find, is what causes the function to equal 0. So we know -2 works. So then now we have to take this trinomial, and in this particular case, I believe it's factorable, but sometimes it won't be factorable, and we might have to do the quadratic formula, but this one does look factorable to me. So we're going to go ahead and factor this, just doing guess and check because it's a fairly simple one. Okay, so I know that to get 2x squared, it's 2x and x, right? Now I got to figure out, how do I get the 3, but add up to -7 in the middle, right? Well, since it's negative in the middle, it must mean that the numbers I'm looking for +3 are -1, -3. But it's a matter of figuring out where they go. And from experience, I know that the -3 will go here and the -1 will go here, because you can see that the inner and the outer will add up to that -7 that I wanted in the middle. So if I switch the 1 and the 3, if I switch spots, it won't add up properly to -7. And so it just kind of takes experience to be good at that. But that was guess and check for that. Okay, so the last part is to list all my solutions. So the first one would be +1/2. Second solution would be 3. And then the last one's going to be -2. So there are my solutions to that polynomial. Okay, let's try a couple more. Okay, so looking at this one here. Um, so first we list our possible solutions. This one isn't too bad. So let's see, +1, 2, 3, and 6. And then on bottom, it's just going to be ±1 from the front right there, okay? And so since you're dividing by 1 and -1, you just have basically your possible rational solutions are all your top numbers up here. So we'll start with 1. So let's see how that works for us. So let's see. Drop the 1. And unfortunately, the remainder is not 0, so we got to try something different. So let's try -1. And this one works out for us. We got a remainder of 0, so that's nice. Okay, so once again, just to kind of emphasize what's taking place is we've basically factored this original polynomial down to x squared plus 3x minus 6. And the other factor would be x plus 1, because if you plug in negative 1, it's one of the solutions to the polynomial. Now, this time, this is not going to be factorable. You can try, what multiplies to give you negative 6, but add to 3 in the middle. You're going to have a tough time. It's not going to work out nicely for you. So what we're going to have to do here is do the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And so this is your a, your b, and your c values right there. So we'll go ahead and fill them in and do the algebra, and it should work out fairly nicely. Okay, so here we go. X equals, so it's going to be negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 6, all divided by 2 times 1. Okay, we'll just clean this up and we'll have all our solutions. So let's see, x equals negative 3 plus or minus the square root of 9. And multiply all that together, that'll become plus 24, all divided by 2. And then negative 3 plus or minus the square root of 33, all over 2. Okay, so that just, remember the plus or minus, that's actually two answers. One with plus, one with minus, and then your other answer was negative 1 right here. And so when we list this, let's see, we have negative 1 as a solution, we have negative 3 plus the square root of 33 over 2, and then we also have negative 3 minus the square root of 33 all over 2. Okay? All right, I'm going to skip this next one. It should be pretty similar to the one we just did. Very, very similar. You got to do the quadratic formula and stuff. I'm just going to go ahead and skip to my last example. Okay, so looking at this one, you'll notice that the polynomial we're looking at is to the power of 4. So we might have to do synthetic division twice on this. So once again, let's go ahead and list our possible solutions. There's not going to be a lot of them, actually. So let's see, on top we put all the factors of 4, so plus minus 1, 2, and 4. And then on bottom, the factors of 1, so just 1. Okay, so we really only have 6 possible rational solutions. 1, negative 1, 2, negative 2, 4, and negative 4. So let's go ahead and try one of these. So we'll go ahead and try 1. So let's see, 1, negative 2, negative 5, 8, and 4. So here we go. And it looks like this first one is a no-go. Doesn't look like 1 works. Okay, so we'll go ahead and try negative 1. Okay, so here we go. And it looks like this one's not working out either. Looks like I did a little right there that should be positive too, but it actually won't make a difference. But let me fix that though. So let's see, that would be 10. 10 times negative 1 is negative 10, adds up to negative 6. So still doesn't work, but yeah, I made a little mistake there. Just make sure we caught that. Okay, well, hopefully, let's see if 2 works. Okay, so let's see, 1, negative 2, negative 5, 8, and 4. So drop that down. Let's see. Adds up to 0. That gives us 0, negative 5. Negative 5 times 2 is negative 10. That adds up to negative 2. We get negative 4. Remainder 0. Yay, yay. Okay. So basically what we've done is we've factored this into x cubed, and then that's like a plus 0x squared minus 5x minus 2. And then the one that I figured out, so x minus 2, that's basically my factor that I got from that being a remainder 0. So that polynomial, I basically factored it. But what do I do with this now? I can't factor this right here. So I'm going to have to continue doing synthetic division. Now, you can start all over if you want, but the thing is, you've already tested 1 and negative 1, so there's no point in trying those again, okay? Now, 2 worked. It's possible that 2 could work again. Now, I'll just tell you right now, I know it doesn't because I've already worked this problem before, but it is possible that that when you do this, that it could, um, 2 could work multiple times. Okay, but let's go ahead and jump to negative 2 though instead. So we're going to do negative 2 and I'm going to do synthetic division. So I'm going to grab these right here. I'm going to grab the 1, 0, negative 5, and negative 2. And this should work for us. Let's see. Drop the 1. 1 times negative 2 is negative 2. Adds to negative 2. That gives us 4. That adds negative 1. Multiplies to a positive 2, adds to 0. So I got another one of my solutions. So what that leaves us with here is x squared minus 2x minus 1. That's what my remainder or my quotient was. And then I know that x plus 2 was one of my factors because I know that negative 2 is a solution, right? If I were to plug in negative 2, this would cause it to equal 0. And then I don't want to forget about the other one I found, so x minus 2. So basically what I've done is I've taken that original polynomial and I'm basically factoring it by these techniques here. Now that I'm down to the trinomial, you'll see that it's not factorable. Okay, so that's not going to work. So we're going to have to go back to the quadratic formula. So I'll go ahead and do that over here. Okay, so here are your A, your B, and your C. So we're going to have negative 2 plus minus the square root of negative 2 squared minus 4 times 1 times negative 1 all over 2 times 1. And just like the other one, I think this one should work out fairly nicely. So let's see, here we go. X equals, this will become a positive 2 plus or minus the square root of 4, and then that becomes a plus 4 once you multiply all that together, all divided by 2. Okay, and so then we're going to end up with 2 plus or minus the square root of 8 all over 2. Okay, now the square root of 8, if you leave it like that, you're not going to get your full credit because we can simplify that. So we're going to go ahead and break the square root of 8 into square root of 4 times square root of 2. Okay, so we broke that apart. Now the square root of 4 is 2. So we're going to get 2 plus or minus 2 square roots of 2, all divided by 2. And they all are divisible by 2. All these are divisible by 2. Now leave the radical alone. Don't ever mess with that when we're doing the quadratic formula, except to simplify it if possible. So that'll simplify into 1 plus or minus square root of 2. If you want to put the 1 in front, it's not really necessary. So there are 2 of your answers, and then the other 2 are from up above over here. So your solution set is negative 2, positive 2, 1 plus the square root of 2, and 1 minus the square root of 2. And once again, the order that you put those in doesn't actually really matter, but there were your 4 solutions on this one. Okay, I hope those examples help.